we probably only have time to do this one way, so I'm going to do it the way that is going to be more versatile. So let's do it with the limit definition of the derivative as a function. So f prime of x equals the limit as h approaches 0, or delta x approaches 0, of f of x plus h minus f of x over h. And for this particular function then, we're going to have the limit as h approaches 0 of the square root of x plus h minus the square root of x over h. Now, you could probably guess, this is always going to happen, but if we try direct substitution right now, what's going to happen? 0 over 0. And the reason we get 0 over 0 is this difference quotient right here is the slope formula with 2 points that are basically on top of each other. So it's always going to be 0 over 0 because it's the same point right now. So we need to change it. This one's not as easy. We can't just say, okay, well, this is the square root of x plus the square root of h, so the square root of x is cancel, and it's easy. That's not true. So does anybody have any ideas how I could manipulate this using things that you know from pre-calculus to look different? And really, most of the manipulations we're going to do, we're just going to try to change the way it looks and see if it works. Any ideas? Nope. Nope. That's kind of what he was. You could try that. That's not a bad idea. Since we have square roots, you want to get rid of square roots. Actually, that might work. There's actually an easier way. Rationalize the numerator. Now, most of the rationalization you've done in your previous career has been rationalizing a denominator. And that's a convention that dates back a long time ago before calculators, because when you had to do calculations using tables and books, it was a lot easier to divide by a whole number than an irrational number. In fact, nearly impossible to divide by an irrational number. But it's also a process that's very useful for manipulating expressions like this. So to rationalize the numerator here, what would we multiply by? The conjugate, the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. And so what's going to happen in the numerator then is we're going to have x plus h, the square root of x plus h squared, which is x plus h, minus the square root of x squared, which is x. And that's all going to be over h times that conjugate, the square root of x plus h plus the square root of x. Worse? Why is that worse? Look what's going to happen up here. What's going to happen to those x's? They cancel. Okay? So the x's are gone. Now we just have the h up here, and we have an h as a factor down here. What's going to happen with those? They're going to cancel. So we're left with 1 in the numerator and just our conjugate in the denominator. Now can we use direct substitution? Yeah, we're not going to get 0 in the denominator here, so we can use direct substitution. So this is going to be, I'm going to take an extra step here than what we normally do. The square root of x plus 0 plus the square root of x in the denominator. Now the square root of x plus 0 is really just the square root of x. So we have in the denominator the square root of x plus the square root of x, which is 2 square root of x. So the derivative of the square root function is 1 over 2 times the square root function. Now, I should not have put a box around that. That's an intermediate answer. I don't like to put boxes around my intermediate answers because that kind of implies that it's a final answer. What we really want to know is what f prime of 2 is. So to figure that out, we're going to put 2 in for x here and get 1 over 2 square root of 2. You do not have to rationalize denominators. Woohoo!